Hello, and welcome to this video on factoring trinomials. And this video is going to focus on using the area model to factor trinomials. That is going to be the method that I am modeling and the method that I'll use in the practice set for going over the practice problems. Please like and subscribe if you find this video helpful. Drop a comment or question below to engage. And this is definitely a concept where there might be some comments or questions about the way this method works. Check out the other videos on the channel and especially check out how to factor using algebra tiles, because that is going to tie in very closely to the area model. The area model comes from the modeling with the algebra tiles and a comparison of factoring methods. So you might be watching this video and thinking, ooh, my teacher uses this other method. We use factoring by grouping, or she taught us, or he taught us slide and divide for factoring, whatever method. And so there is a video also comparing the different methods so you can see how they're similar and how they're different from each other. Now, I feel like I've said this in a million videos and it's probably going to continue. They are replacing a floor in the apartment above me, and it can be quiet for a while and then they'll be like pounding and sanding, and pounding just started. And I am so sorry, but the alternative is I don't record videos, or I record them at like 3 in the morning when they're not doing work up above me. So I apologize for that if it is a little bit distracting. So what are we doing when we factor? This is one of those things where the directions need to make sense, and we need to have a sense of what we're doing. What are we trying to do? When the directions say factor, what are you being asked for? Well, first off, factors are what is multiplied to give us the product. So at its most basic level, you might have 4 times 5, and 4 and 5 are the factors. They are the things that are multiplied. And 20 is what is known as the product. It's the result of the multiplication problem. So when you are asked to factor something, you are given the product, okay, and you're being asked to find the factors. Now, if you were asked to find the factors of 20, there are multiple correct answers to that. But when you are asked to find the factors of a trinomial, there's actually only one correct answer. You won't find different combinations of binomials that will give you that trinomial. And so there's only one thing to do. It's just one thing to find. It's just a matter of finding a strategy so you can figure out what those factors are. Now, we are reversing the process of polynomial multiplication. So in polynomial multiplication, you might have, actually, I think, I do have an example there. Okay, so in polynomial multiplication, you start with something like this, x minus 5 times x plus 3, and you go and multiply it together and you get x squared minus 2x minus 15. In factoring, you're going to start with the x squared minus 2x minus 15 and find the x minus 5 and the x plus 3. And again, there's only one correct combination of factors. It doesn't matter what order they're in. So you could have x minus 5 times x plus 3 or x plus 3 times x minus 5. The order doesn't matter, but those would have to be the correct factors. So we're reversing that process. The better you are at multiplication. So if you did all your homework, all your practice problems, did some extra stuff, clicked on the practice set for this video series, whatever you do, you go onto the interwebs and find practice problems. The more multiplication you have done, the easier it is going to be for you to reverse the process, because it develops this inner sense of how these numbers work and come together. Now, how is this represented on the area model? Because that is how we are going to be factoring. Well, we are being given the area and we're going to be looking for the factors. Okay, so in this sense, we're going to be given the areas and we're looking for the base and the height. So if you had x squared minus 2x minus 15, that is the product. That is the area. And so inside our rectangle, we are going to need to put this x squared minus 2x minus 15. We're going to need to figure out what goes into each box. And then once we have that, we'll be able to find out what multiplied gave us those individual areas, and that's going to give us our factors. So starting with the first example, this is kind of like a walkthrough example, and then I'm going to summarize the steps for you. So I'm going to kind of walk you through an example, follow along with what I'm doing, copy it down in your notebook, do what you need to do, and then I'll summarize the steps for you, and then I'll do several other examples after I have summarized the steps so that we can kind of see the picture, and then we'll home in on the details, and then we'll try to put it all together. If you've used the area model for your multiplication, okay, and I teach multiplication with the area model because I want my students to be familiar with this strategy heading into it. You know that when you are filling it out, your x squared term always ends up in that upper left, and your constant term always ends up in the lower right. And so I'm going to go ahead and put those in. The 2x squared and the minus 15. And again, if you've done a lot of the binomial multiplication, that's going to feel very intuitive. Like, yeah, sure, I agree with that because I've done a million of these using the area model, and I know that's where the x squared always shows up. It shows up in the upper left, constant shows up in the lower right. Now, here's the tricky part. Okay, these two, when you're doing the multiplication, you end up adding these two together. Okay, and when you add them together, that's what gives you the middle term. So we need to find two things that have an x on them that add up to -7, because we want the area to represent this entire polynomial. So we're going to have 2x squared minus 7x minus 15. Here's the problem. There are an infinite number of things that add up to -7x. So I'll give you an example. You might have negative 6x and a -1x, okay? That would add up to -7. But you could also have -5x plus -2x, like that also adds up to -7. You could even have something like 1x plus -8x, okay? That would add up to -7. And you could keep going on this like forever. There's an infinite number of things that add up to -7. We need the right combination of things that add up to -7, because only one of them is going to work for giving us the factors that were multiplied. So here's what we need to do, okay? And this is where it gets a little weird. We're going to take the 2, and I should underline the negative. We're going to take the 2 and the -15 and multiply those together. You're like, I don't know why you're doing that. You'll see. Now, we're going to find all of the factors of -30. You know, full disclosure, okay? I will ignore the negative on the 30 for now, because what I don't really want to do is this. I don't want to do -1 times +30 and +1 times -30. Okay. Yes, both of those multiply to -30, but it feels not duplicative. Not duplicitous, maybe it's duplicative. It's duplicating my work, okay? And so that just feels like a lot when I'm just moving the negative around. So I am just going to focus on the pairs of factors, and I'm going to deal with that negative when I'm done. So what are the things that multiply to give me 30? Well, 1 times 30, 2 times 15, 3 times 10, not 4, okay? And this is where we get into divisibility rules. Not 4, because when I multiplied by 2, I had an odd number out here, which means that I don't have another 2, so not 4. But I do have 5. And once you end up with the numbers that are closest to each other, so you'd end up like duplicating your numbers. So after 5 would come 6, but I already have a 6 there. Then you know you've got all your pairs of factors. And hopefully the number isn't too huge. The bigger that number is, the more combinations of numbers you have to look for and the harder it can be. And that's across the board. Now I want to find a pair of numbers that can give me that -7. Remember earlier I said there's an infinite number of things that can give you -7. We need the right pair. So looking at the 1 and the 30, I can't get a 7 by adding that at all. I could get a 31 if I added them together, and if I make one of them negative, I could get a 29. Okay, I mean, it could be positive or negative of either of those, but not a 7. 2 plus 15 would give me 17, and if I subtract them, I could get a 13, but not a 7. 3 plus 10 gives me 13, but if I do 10 minus 3, I can get a 7, okay? So 10 minus 3 does give me the 7, so that looks pretty good. And then looking at the 5 and the 6, if I add those, I get 11, and if I subtract them, I get a 1. So this is my combination. This is the one that gets me the 7. The problem is 10 minus 3 gives me positive 7, and I need negative 7. So this is where that like negative comes in to play. Instead of having a positive 7 and the negative 3, I'm going to go ahead and say, what if it's negative 10? I thought I said a positive 7, and I meant a positive 10 and a negative 3. A negative 10 and a positive 3, that would give me the negative 7. So just to double check this, because there are ways that like things can end up duplicated, okay? So I'm going to double check, and I'm going to say if I have a negative 10 and a positive 3, that does multiply to give me negative 30. Okay, so that's what I needed. I needed that negative 30. If I do negative 10 plus 3, that gives me negative 7, which is what I wanted. So this combination of numbers meets both of the requirements for the multiplication and the adding. So that tells me how I am going to break this up. So I'm going to do like a negative 10x here and a positive 3x there. And it honestly doesn't matter. So if you wanted to put the negative 10x on the bottom left or in the 3x in the upper right, like that's fine as well. Now here's where this strategy is pretty awesome. Okay, so what I've done is I've got this area which matches my product. Now I just need to find the base and the height. I am going to do greatest common factor factoring in one direction. So I can take these two, find the GCF, and write it up here. I could take these two, find the GCF, and write it up here. I don't recommend that because knowing what to do with the negative is a little bit tricky sometimes. I can do a GCF this way, okay, and write the GCF there, or I could do the GCF right here and write it out there. I strongly recommend that you pick the easiest direction, which for me is going to be this way, writing the GCF up here. The reason I'm going to pick that is because 2 and 3 do not share any common factors, and they're both positive, so I'm going to try to avoid those negatives if I can. The greatest common factor between 2x squared and 3x is x. Now, to finish the problem out, you can either continue your GCF factoring. Remember, I said you can do it in any order you want, or you can just use multiplication if you have multiplied using the area model. So here's what I mean by that. What times x would give me the 2x squared? Because remember, this is the area, and you've got the base. What would the height have to be? Well, the height would have to be 2x, so 2x times x would give you 2x squared. Looking down here, you've got the base is x, the area is 3x, so what does the height have to be? The height would have to be 3. And then you can do either one. You can work with the 10x or with the negative 15. I'm going to go ahead and work with the negative 15. The area of this region here is negative 15. The height is positive 3. Therefore, the base must be negative 5, and you can use your fourth box as a check. Does 2x times negative 5 give you negative 10x? Yes. So each one of these boxes matches up. If you do base times height, base times height, base times height, base times height, all of them work. The area matches what we have up here, and therefore my two factors are the base, which is x minus 5, times the height, which is 2x plus 3. Now, that was a very, very long explanation of this strategy because I walked you through the whole process in detail. The next ones should pick up the pace a little bit more until eventually this gets to be fast or faster than other methods you might use. So you just kind of have to hang with it. Okay. So that's our walkthrough example. Here's the steps. So if you want to watch this slide and then pause the video, write down the steps so you can go back and reference them if you need to. All right. factor out any greatest common factor. That's always the first step in any factoring problem. And we do get a little bit lazy about talking about it. Like we'll kind of talk about the GCF and we'll sometimes do it. And then we see so many problems where there is no GCF that we kind of forget about it. But always, always, always look to see if there is a GCF. If there is, you want to factor it out first. Then you can fill in the upper left and the lower right. So you can go ahead and fill in this with your x squared and this with your constant, whatever your constant is. That will always be consistent. Then we get to multiply the a and the c value. So that is your ax squared plus bx plus c. You're going to take your a value and your c value and multiply those and find two factors of those that add up to that b value. So what you're doing is you're looking to find out how am I going to break that b value up into those other two squares, and you've got to do it by factoring the product of a times c, and you just kind of cross your fingers and hope that you don't have like an awful number there. Fill in the upper right and the lower left. So once you have that, you'll have your two x terms to fill in the upper right and the lower left. GCF factor in one direction, and take a moment and see what is the easiest direction. Like, where do you have the smallest numbers? Where do you have the fewest common factors? Where do you have stuff that's positive and not negative? Just kind of look at the four directions that you've got available. Usually it'll be either the top row or the left-hand column. Okay, that's usually where we start. And then use multiplication, or if you really want to continue factoring, you can, but most students do prefer to use multiplication to get the rest. It's a huge advantage to this system because you just have to do one little GCF factoring. And then make sure that you write out all the factors. So make sure that your final answer does look something like this. If you got a GCF, it'll go out front if you have one. I have a lot of students that will finish the model and then just leave the model and they never actually state what the factors are. So again, if you want to pause the video right here and just kind of write this down or take a picture of it, maybe take a screenshot on your computer, your phone, whatever, so you can go back and look at the steps. And let's keep going. All right, so these are 3 additional examples, and I will try to pick up the pace a little bit. So we have x squared minus 9x plus 18. So we do not have a GCF there. And I know that real fast because my first term only has x's as factors, and my last term does not have any x's as factors. Therefore, there's nothing that all 3 of them have in common. So no GCF. Okay, fill in the upper left and the lower right. Now we're going to take the a and the c values. So 1 times 18 is just 18. And now that gives me like a way to limit the number of factors because there's an infinite number of things that add up to -9. I need the pair that will also multiply to give me the 18. Okay, so that 18 kind of reins us in and brings us down from infinite to what we hope is a smaller number. So we've got 1 times 18, we've got 2 times 9, and 3 times 6. We're looking for the pair that will give us the 9. I can get a 9 from the 3 and the 6 if they are both negative. So we'll do a quick check on this before we plug it in. -3 times a -6 does give me a positive 18. -3 plus -6 does give me a -9, and you do want to check both of those. There are a couple of like problems where you'll have multiple choices and one of them won't work. So I'll go ahead and split that up into -3x and -6x. You can do it the other way around, that's fine. And now we're going to GCF factor. I'm going to GCF factor going straight across here. X squared and -3x. The greatest common factor is x. And now I can do multiplication for the rest. So x times what would give me x squared? If the area is x squared, then this would have to be an x. X times what gives me the -3x? Well, that's -3. X times what gives me -6x? That's -6. And then you can use your last box as a check. -6 times -3 is positive 18. And so my factors are the base, which is x minus 3, times the height, which is x minus 6. Ta-da! All right. Next one. This one also does not have a GCF, and I know it does not have a GCF because 17 is a prime number. So this one does not share any x's. 17 is prime, meaning it's not going to share any factors with the 6 and the 3. So starting off, we're going to put the 6x squared in the upper left and the negative 3 in the lower right. And then we're going to multiply our a times our c. So 6 times negative 3 is negative 18. And again, that is to rein in our possibilities. There are an infinite number of things that would add up to negative 17, but we don't want an infinite number of things. So the 18, we actually did this like in the last problem with all the pairs of factors. So I can have 1 times 18, 2 times 9, or 3 times 6. The number we're looking for is negative 17. So let's kind of looking at the 1 and the 18. Yes, I can get a 17 from that if I subtract them. Okay, I can get the 17. 2 and 9, if I add them, I can get an 11. If I subtract them, I can get a 7. So not that one. And 3 and 6, I can get a 9 or a 3 if I subtract. So my pair of numbers is going to be the 1 and the 18. Now they've got to add up to negative 17, which means the 18 must be negative. And before I plug them in, I'm going to do a quick check. 1 times negative 18 gives me negative 18. 1 plus negative 18 gives me negative 17. So that lets me know I've got the right pair of numbers. We have 1x, and then we have negative 18x, and now we need to look for a greatest common factor. I'm going to try to avoid those negatives, okay? And I'm going to try to avoid the 18, quite frankly. It's kind of a big number. So I'm going to go this way right here. 6x squared plus 1x. Well, what's the GCF? X. And now I can use multiplication to get everything else. X times what gives me 6x squared? Well, this must be 6x. X times what gives me 1x? That must be a 1. And then again, I'm not a huge fan of that negative 18, so I'm going to work with the negative 3 here. 1 times what would give me negative 3? Well, that would be negative 3. And now I'll use the 18 for a check. Negative 3 times 6x is negative 18x. So again, each one of these areas needs to check. 6x times x is 6x squared. X times 1 is 1x. 6x times negative 3 is negative 18x. And negative 3 times 1 is negative 3. And there's my base, and there's my height. So there's my factors. So 6x plus 1 and x minus 3. Okay, last one. Remember to check for that GCF, and this one does have a GCF, and that is excellent news, okay? Because if I don't get the GCF, then my next step would be to multiply a times c, and 4 times 24 is equal to, I'm probably not going to do this problem because that number is going to be huge, and I'm going to be looking for pairs of factors that add up to 28, and the numbers are just going to be really big. Now, can you get factoring problems where the numbers are big? Yes. If you do, please go back and check for a common factor. Just that is one of the things that might be a tip off that like, ooh, we've got a common factor in there. Now, 4 is a factor of 28 and it is a factor of 24. The x's don't go all the way through. So I'm going to go ahead and factor out the 4. And you can think of it this way. We're going to do reverse distribution. So 4 times what would give me 4x squared? Well, that would be x squared. And then 4, if you were distributing it, times what would give me 28x? That would be 7x. You could also think of that as 28 factor out of 4, you are left with a 7. You can also think of that as division. You're going to do 28 divided by 4. I tell my students factoring and division are very, very closely related operations. Okay, they're not exactly the same thing, but they're very closely related, and you can often get factors by doing division. And then 4 times what would give me the 24? That's the 6. Now, the huge advantage to getting that out is that now, instead of dealing with 4 times 24, I'm going to do 1 times 6, which makes me so much happier in my heart, okay? So we're going to put the x squared here and the 6 here, and this is a 1, so we do 1 times 6, which is just 6, and we want to factor 1 times 6, so 1 times 6, or sorry, factor 6 into 1 times 6, or 2 times 3. The number we're looking for now is a 7 instead of a 28. So much nicer. I can get a 7 if I add 1 and 6. So I believe my pair of factors is 1 and 6. We're going to double check that real quick. 1 times 6 does give me 6, and 1 plus 6 does give me 7. So I am very confident that we'll do it this way. We'll do 6x and 1x. And this time I'm going to do a GCF factor like right here, okay? What is the greatest common factor between x squared and 1x? Well, that would be x. And now the rest of this I can do by multiplication. So x times what gives me x squared? That's got to be x. X times what gives me 6x? That's a 6. X times what gives me 1x? Well, that would be 1, and 1 times 6 is 6. So my factors are the base of x plus 6 and times the height of x plus 1. And don't forget that 4. We had that 4 like from the beginning. So you want to list all those factors. So if you grab that 4 at the beginning, you want to make sure that you list it with the final factorization at the end. Now, notice that those went a lot faster. I've gotten really good at using this method, so much so that it's just about like as fast as any other method I might use. And I strongly encourage you to use it because when you get to polynomial division, which is much further on from this model of structuring your polynomials is going to hold up under your polynomial division. So it is a huge advantage to that. All right, so please don't forget to like and subscribe for more math help. Drop me a question or make a comment below to engage. And I'd love to hear from you about whether you like this method, whether you found that it made more sense or not, or check out the practice set, which I'll link in the description box for this lesson, and check out the other videos on factoring. So there is a factoring with algebra tiles, which takes this method and makes it extremely hands-on, so you can actually manipulate tiles and find the factors, and a comparison of factoring methods. So I'll try to link these in a card above. I'll try to put one of them in the card like up there, and I'll try to put the other one like in a link over here in the end screen so that you can check out those videos, and the practice set will be linked in the description box as well. So thank you for hanging with me through this. I know this is longer, but this is a critical lesson, and I hope to see you in the next one. Stay with us for more factoring.